We're going to start with our notes today. So the first thing you have is a warm-up on here. So I'd like for you to push pause on the recording and take a moment to solve the two questions that are on your warm-up. So the first one is to find the hypotenuse, and the second one is to find the missing side. In case you have forgotten, we have a right triangle. So you're looking at your Pythagorean theorem, which is a squared plus b squared equals c squared. So pause now and then come back when you're finished. All right, so let's check your answers here. So for number 1, you should have had 77 squared plus 118 squared equals c squared. And then, all right, there it is. And then that's going to equal, when you solve that, you're going to get 19,618 equals c squared. And then to undo that c squared, you're going to have to take the square root. So you should have gotten c as a value of 140.9, or 140 and 9/10, I should say. For b, you should have set it up, but this time you're solving for the letter b, for number 2. So 77 squared plus b squared equals 98 squared. You're setting this up as an equation, so you're going to have 98 squared minus 77 squared. B squared is going to equal 3,675. In order to undo the b squared, you're going to take the square root of both sides. And so for the letter, or the side b, you should have gotten 60 and 6/10 units. Okay. So what we're looking at is conditional statements. So let's look at the statement, criminals get caught on CSI. So the show CSI, criminals get caught. We're looking at writing that as a conditional statement. And conditional statements are one of those things that we're going to look at while we're solving with proofs. And in order to do conditional statements, we use what's called an if-then statement. So when you are writing these, what you're looking for is if something happens, then this is the consequence. So this is what we have by what we call an if-then statement. So we use the letters P and Q to represent these. You're going to see this throughout math where we're using letters to represent full statements. So we have this P is the if statement, Q is the then statement. So if you look at down here, if I say P actually represents the words snow 6 inches and Q actually represents the words we won't have school, then here is your statement. So we have P to Q. So if, think about it this way, if it snows 6 inches, then we won't have school. Whereas the other statement says, if we don't have school, then it snows 6 inches. Now one of those statements is true, the other statement would be considered not true, because we could not have school and it could be less than 6 inches as well. Okay, so let's look at a converse. If you are a criminal, then you will get caught on CSI. That converse goes the same thing as with the snow with the 6 inches. Just because you're a criminal doesn't necessarily mean you're going to get caught. All right, so that would be a converse of the statement of what we had previous. That would actually be then your statement and then if. So they're actually written backwards for that converse. Okay. So here's our conditional statement. If you are on CSI and you are a criminal, then you will get caught. That's our conditional statement. The converse of that is if you get caught on CSI, then you are a criminal. All right, so if you'll notice that when we're looking at the converse, we're actually switching out those if-then statements. Now, decide if it's true or false. So your conditional, true or false, make your decision. And the same thing with the converse. A biconditional, notice it here because we have the arrows going in both conditions or both directions, all right, is if and only if is the difference there. So conditional is an if then, a biconditional is an if and an only if. Okay, so P to Q and Q to P. P, if and only if Q. So a biconditional for the statement. You will get caught on CSI if and only if you are a criminal. So it's just a way of rewriting these statements. And sometimes you have your conditionals, your converse, and your biconditionals, and then you've got to make a decision, is it true or not true? And what we'll be using this for is a lot when we're looking at similar and congruent figures. Notice the symbol is there. We try to, in math, so that we don't get lengthy proofs or we don't get lengthy descriptions, we use a lot of symbols, mathematical shorthand, if you will. And notice the if and only if, this is the symbol that you would use for that. Okay. So the whole idea behind today's lesson is looking at ways to understand the definition and writing those biconditionals. Part of the challenge is knowing your symbols and what is actually being said. Many times you might know the idea, but because you don't recognize the symbols or you don't recognize how it's written because it's written different than something you've seen before, it's going to cause you to miss something. So we want to stay away from that. All right. So I want you to pause this, write definition of a midpoint of a segment AB. So just pause it, write it, and then push play. Okay, here we go. The midpoint of a segment AB is the point M on AB such that AM is equal to MB. Okay. Properties of a good definition, they have to use known terms. So you can't use a term that you've not defined before. It has to be accurate and it has to be concise. Okay. If you did not use accurate terms, so let's look at this. A number, and we have a point and a line. So a number, an absolute value, between, and then we have coming down from absolute value, you have distance, and we're looking at midpoint of a segment. Okay, so these are key words. Midpoint of a segment AB is the point M on AB such that AM is equal to MB. M, in this situation, M is not on line segment AB. See how that looks? So the definition and making sure we're using those accurate terminologies make a difference. So what we're looking for, midpoint of a segment is a point between the endpoints. The statement does not accurately describe a midpoint. Okay, so it violates some of the properties. Midpoint of M of segment AB is the point of M on AB between A and B, the same distance from A and B, so that MA is equal to MB. That's too much information. It's too wordy. If it's too wordy, it doesn't work. The midpoint M of AB is the intersection of segment AB and a bisector of segment AB. So what do you think? Okay, so this one uses the term bisector, which we have not identified yet. So we can't use that one. It's an unknown term. Okay, so we're looking at these. Why is this one not good? Think what you read it, think about it, and then let's look at the answer. Okay, circles around figure. Think about it. Why is that not a good one? Which property of a good definition does this definition of a square violate? Square is a quadrilateral that has 4 90-degree angles, opposite sides that are parallel, and I should say and congruent sides, or yeah, and congruent sides. Sorry, my head bubbles in the way. So what does that violate? It's not concise, it's too wordy. Okay, so let's look at this. Here's a problem. I want you to pause, try to find the answer to this, and then come back to the answer. So pause me now. All right, so let's look at this answer. So we know that they're equal to each other. So x equals 3. And then we're going to substitute that 3 back into our equations, and we get GI is equal to 32. Okay. Write a definition of a midpoint of a segment. Let's look again. Midpoint of a segment AB is the point of M on segment AB with AM equal to MB. Now, take that same definition and write it as a biconditional. So take a moment, try it, pause me, and then come back. So M is between A and B. AM plus MB equals AB. So we want to write this as this means a biconditional. So notice our first statement is our P, our second statement is the Q part. So take a moment, write it, and then come back to me and look at your answer. Okay. M is between A and B if and only if AM plus MB equals AB. So there's that same definition written as a biconditional. So if it's a good definition, it's easy to break down, and we can easily write it as a biconditional, which is what we want to show that it's as accurate as possible. All right, don't worry about this practice. We're going to come back to this. Actually, let's go ahead and add this practice to our assignment sheet. I think you're going to have time today to do it and not have to have any homework. So let's try this. Let me write it down to make sure. I'll go ahead and update it into Canvas so that you can make sure that you get it in there, okay, for your grade. All right, so closure on this lesson. There are some questions to answer. I'm just going to go through them. Question pops up. I want you to pause it, try to answer it, and then come back to the answer, okay? So you can work at your own pace on that. This is where you pause it. Okay, so let's look at the solutions of those. If you need to go back and take time to answer them, you can.